where is the best place to start tackling this? Well, to me, the easiest place to start is actually with the depositing, right? Because that's the first thing people are realistically going to do with this protocol is actually deposit the collateral. So I'm going to start there. So for this deposit collateral function, what are they going to want to do here? Well, we're going to need to let them pick what collateral they want to deposit. So we'll say address token collateral address, and then also the UNT56 amount collateral. And we're going to do a little toggle word wrap. All right, cool. So deposit collateral, the token collateral address, and then the amount that they're going to want to do. So already we can see that there's going to be a whole bunch of stuff that we're going to want to do here. So let's even do a little bit of NatSpec, here. We'll say @param. We'll just explain what the params are. And this is where GitHub Copilot is really helpful because oftentimes it's really good with docs. So we're going to say @param, param. So both of those look good. Token collateral address, the amount of token to deposit as collateral, amount collateral, the amount of collateral to deposit, right? Real simple. So we're going to want a couple of things here. We're going to want to sanitize this a little bit. So the amount collateral, we're definitely going to want this to be more than 0. So we're probably going to want a modifier called more than 0 that we can use throughout these functions. Sometimes people might accidentally send a 0 transaction. We want to automatically revert those. So if we scroll up to the top here, we can see our modifiers come before our functions. So we're going to create our modifiers here. And we're even going to add like a little section, a whole bunch of these here. Boom, 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 boom. Modifiers like this. Cool. And we'll say modifier more than 0. And this modifier will take a UNT56 amount. And we'll just say if amount equals 0, then we're going to go ahead and revert with a new error. Where do errors go? Let's scroll to the top. Errors go right underneath imports. Actually, it's not quite right. They're going to go right underneath the contract. So what we're going to copy this whole section. We're going to say errors. We're going to go here. So we're going to say error, DSC engine __. What do we want to call that? It just needs more than 0. Needs more than 0. Like this. And then we're going to revert with needs more than 0. And of course, add the little underscore here. Cool. So now we have a more than 0 modifier. So we can make this external more than 0, and we'll pass the amount collateral. And boom. Okay, cool. We're doing a little sanitization here. What else should we do? And you know what? Let's even copy this. We'll paste this here. We'll say functions, and we're going to have a constructor. So I'm just going to put this here for now. Constructor, I should spell constructor right. And then we're going to have a section after functions, like a subsection. We're going to call it external functions, like this, external functions. Cool. Because we want to go receive and fallback. We're not going to have those, but then external and public. So external function first. Anyways, okay. More than 0. Got that. And we probably don't want people to use any collateral, right? We probably only want them to use certain collateral that we allow. So we're going to have to create a new modifier called isAllowedToken. So we're going to do modifier isAllowedToken. And this is going to take a address token. Basically, we're going to say, if the token not allowed, the token isn't allowed, then revert, right? However, at the moment, we don't have like a token allow list. So let's create that. This is probably going to be a state mapping. So let's scroll to the top. Where do state variables go? So errors, type declarations, state variables. Okay, errors. Great, let's put it here. State variables. Okay, and let's create an allowed list of mapping. So we'll do mapping address to bool, private s_token to allowed. And we could do this. However, I already know that we're going to need price feeds. So instead, what I'm going to do is I'm not going to do an address to bool. I'm going to do an address to address. And this is going to be our price feed mapping. So this is going to be s_price feeds. And normally I do the syntax token to price feed, right? But for this one, we're just going to call this price feeds, and we're going to use the newer Solidity named mappings to make this a little bit clearer. So I'm going to say address token maps to address price feed. So now this is S price feed, and anybody can look up and go, okay, so this is token to price feed. Cool. So we're going to have this list of price feeds. And where should we probably set this? Well, we're probably going to want to set this up right in the constructor, right? Right when we deploy this contract, that's when we're going to say, okay, these are going to be the allowed tokens. These are the price feeds. And that way it's going to be like that forever, right? We're never going to be able to change this. So what we'll do is in our constructor now, we'll take in the allowed tokens and their price feeds, right? Because in order for this system to work, we go to like data.chain.link. In order for this entire system to work, if we want to know how much value our Ethereum that people deposit in here is worth, we need to have the pricing, right? The only way for us to know if we're over collateralized, if we know the value of our ETH and our Bitcoin. So we're going to use these two price feeds to maintain that. Because these price feeds are going to be on different addresses on different chains, you already know that we got to parameterize it. So we'll do an address array, memory, token addresses, comma address array, memory, price, feed addresses as input parameters. And we're going to say token address 0 maps to price feed 0, token address 1 maps to price feed 1, etc. And while we're in here, I already know that our DSC engine is going to need to know about our decentralized stablecoin. Why? Because our DSC engine is going to need to know to call burn and mint. So in here, in the constructor, this is also where we're going to pass the address, DSC address, decentralized stablecoin address. And so in here, let's do some sanity checks on this. We'll say if the token addresses .length does not equal the price feed addresses, price feed addresses .length, we have an issue, right? Because if there's more tokens or more price feeds, that means we messed something up. So we're going to go ahead and revert with a new error. We'll go to our errors here. We'll say error DSC engine __ token address is and price feed addresses must be same length. It's a massive error, I know, but I like being verbose, like I've told you before. So if those don't match, we're going to go ahead and revert. Then we're going to loop through the token addresses and update our mapping that we just created up here to say, okay, the token address is mapped to the price feed address. Now, in order for us to get a pricing, we're going to have to use the USD price feeds, and every price feed that we're going to have to use is going to be the USD backed price feed. So for example, it's going to be ETH, USD, BTC, USD, MKR, USD, etc. Okay. So we're going to loop through. We're going to say for UN256, I equals 0. I is less than token addresses dot length, I plus plus. So we're going to loop through this token addresses array. And we're going to say S _ price feeds of token addresses I is going to equal to price feed addresses of I. So we're going to set up this price feed. So whatever the token, so the token of I is going to equal the price feed of I. And that's how we're going to set up what tokens are allowed on our platform. If they have a price feed, they're allowed. If they don't, they're not allowed. And then I know we're going to do a lot of stuff with our DSC. So this is where this is definitely going to be an immutable variable. So we can scroll up, make a immutable variable. We'll say decentralized stablecoin private I _ DSC, because we're going to make this immutable. And since we're using decentralized stablecoin, we're going to have to go ahead and import this. So let's go to the top here to import decentralized stablecoin from /decentralized stablecoin.sol. So now decentralized stablecoin private IDSC. We can now do, this is going to be private immutable. Go a bit down to the constructor. We're just going to say IDSC equals decentralized stablecoin DSC address, like that. Again, using GitHub Copilot. If you don't have GitHub Copilot, that's okay. There's a lot of other free AIs that you can use as well. Okay. Cool. So we set up our constructor. We're going back down to deposit collateral. The whole reason we were doing this is we're saying, okay, we should only allow certain kinds of collateral on our platform. So now we can create a new modifier called isAllovedToken, where we can just say if s_price feeds of token equals address 0, then we can go ahead and revert with a new, oh, that looks like a good one. DSC engine token not allowed. I'm just going to copy that, go to the top, and thanks GitHub Copilot, just auto-filled it in for me. Okay, great. And then of course we need to do this down here. Cool. So is token allowed more than 0 is allowed token collateral address like this. All right, cool. And then additionally, I'm going to add a non-reentrant modifier here as well. We're going to grab this from OpenZeppelin. Whenever we're working with external contracts, it might be a good idea to consider making your function non-reentrant. Reentrancies are one of the most common attacks in all of Web3. And to be honest, sometimes I'll just rip a non-reentrant modifier, even if I'm pretty certain it's not vulnerable to a reentrancy attack. I feel like, to be honest, most functions should be non-reentrant by default, but especially when working with external contracts, it's a good idea to maybe put this modifier here. Now, this might go to audit and we might say, hey, well, we don't need this non-reentrant modifier and maybe we get rid of it, but maybe we don't. The trade-off is it's a little bit more gas intensive to have this here, but it's also safer. So I'm just going to stick it in here, even if I'm pretty certain I don't need it. We're going to get this from OpenZeppelin has a non-reentrant modifier from their reentrancy guard. So we'll import, actually my GitHub Copilot automatically had it. Reentrancy guard from OpenZeppelin, contracts, security, reentrancy guard.sol. Yep, that's actually exactly correct. And then what we can do is scroll down and we can see our DSC engine is reentrancy guard. And by doing this, we now have access to this non-reentrant modifier. And now this function is non-reentrantable, which is what we want. Okay, cool. Now we can finally start doing some collateral stuff. So we're going to go ahead and deposit this collateral. First thing we're going to need to do is a way to track how much collateral somebody has actually deposited. So what's that look like? Well, that probably looks like a mapping to me. So let's go to the top. We'll create a mapping of address user to mapping of an address token to UN256 amount private s_collateral deposited. So this is a mapping to a mapping. Crazy, right? So we're going to map the user's balances to a mapping of tokens, which is going to get mapped to the amount of each token that they have. All right, so let's scroll back down to our deposit collateral function. So now we have a collateral deposited mapping. So we can do s_collateral deposited of message.sender of this token collateral address. Now that we know it is an allowed collateral address, it's going to be plus equal to the amount collateral, right? And I'm actually running into an issue here where when I do forge formats the code look like this, but right now when I'm saving, it's reformatting in a different way. So what I'm going to do is it looks like it's using a different formatter that I don't like. So I'm going to go to the extensions, Solidity hard hat, hit the settings here, extension settings, and we're going to change this from prettier to forge because I want to use the forge format settings. Now if I hit save, okay, great. It saves and formats the way I want it to. Okay, great. So as you can see here, we're updating state. And what should we do when we update state? We should emit an event. So we're going to emit collateral deposited. We're going to have it be the message.sender who is depositing the token collateral address and the amount collateral as well, which means that we have our first event. All right. So let's go on up here. Zoom back out. Scroll all the way up to the layout. Where do events go? Events go after the state variables. Okay, so I'm going to copy this. They go right after the state variables before the modifier. So we're going to say events. We're going to go here. We're going to say event. and GitHub Copilot automatically filled it in for me. Awesome. Address indexed user, address indexed token, UN256 amount. We don't really need to index that. Maybe we do. Why not? Let's just index it. All right, cool. And just to note, a keyboard shortcut that I use a lot is Control back or Control minus, which allows you to go back to the last spot you were in your code. If you do Control Shift minus, it'll go forward. And I use this all the time. So for example, if I'm way down here in my code and I hit Control back, I'll just go right back to the last place my cruiser was. And I use this all the time. I'm not sure what the keyboard shortcut on Windows or Linux is, but on a Mac, it is Control back and Control Shift back, and I use it all the time. Anyways, so we are in deposit collateral. We have this emit here. We finally have the event, and okay, cool. So we're updating the collateral, internal record keeping. We're emitting event. Now, of course, we should actually get the tokens, right? And you can see here, we're following CEI, right? So you do a little notice follows CEI, checks, effects, interactions. So all the checks are happening in our modifiers here. These are all the checks. Our effects are right here. And then finally, our external interactions. So this is where we're going to do that transfer from. And we're going to need to wrap our collateral as an ERC20. So we're going to need to call transfer from on it. So I'm going to go ahead and import IERC20 from at open zeppelin/contracts/ token /ERC20 /IERC20.sol, Control minus to go right back down to here. Isn't that nice? And we can finally do IERC20 of the token collateral address dot transfer from message.sender to address this amount collateral like this. And we'll say, so this function actually returns a Boolean, bool success. And we want to make sure that this is actually being true. So we want to say if not success, we'll just revert DSC engine underscore transfer failed like this. What's this? An error? You bet it is. So we're going to put this at the top. Error DSC engine transfer failed. And I'm going to hit Control minus to go right back down to the code that I was working with. Okay, cool. So this function looks pretty good to me. I'm able to deposit collateral in here and update our mappings. Now might be a good time for us to start writing some tests for this, right? And we could do something similar to what we did before, where we just kind of threw together a real quick setup in our unit tests and then had our integration tests be what our deploy script actually uses. Well, let's write a couple more functions first, and then we can go ahead and do all that work.